I don't even know if that's the right one for this. Yeah, I just don't know if that's the first one for this session or not.
Thank you so much.
You're still seeing it, right? Yeah, I don't know. I don't know if that's is that one of the slides for this session?
No.
Okay, yeah, we're just probably pulling out to test it, huh?
I need to copy this one.
Yeah, go ahead.
Same basic routine. You've already recorded. Thank you.
Just she changed her slides actually. Now then I need to copy this thing to the last minute. Ah, come on. Yeah. Maybe we can. Oh, come on. Okay. Where is the other one? Maybe I know how this one works. Where is the? Do you know how to open this one? USB. I closed it. I don't know this tab thing. I don't know.
I want to open it now. If you go to my computer, wherever that
Just I remember when you put it back.
computer. Let's computer.
And I did it.
Yeah.
Oh, thank you.
Who's that?
These guys. Yeah. So now I need to put this. You are better, Maria. So this one 17.
Mm-hmm.
This one need to be deleted. This is the one she wants to take. Yeah. No. This. How can I change?
You copy it.
Oh, it's already copied. Yeah. Delete. And then give this one to 17. Yeah, enter or how do you to change the rename? Oh no, it's fine. Here 17 hyphen. Okay. Okay.
Alright, let's put that's fine, no?
Okay.
Okay, so we can
Okay. He's which one now? The 16.
Okay, everyone, we're gonna make a start. It's a pleasure to be chairing the last session of the day. My name is Maria Secrier, and I'm happy to introduce our first speaker, Francisco Ortuno from the University of Chicago, who will be talking to us about building and using a Gen3 data commons for translational medicine. How do we put the slides on? We put it full screen.
Because it's changing the connection.
Oh yes, they did. I don't know why. But I think maybe if I can, because I could see a bit of it. Maybe if I just drag it there, somewhere. No. There. View. Full screen mode. Oh,
Thank you very much for coming this late session. I really appreciate that. And as she said, my name is Francisco Ortuno. I'm senior bioinformatician in the University of Chicago, and I'm going to introduce you to our Gen3 technology to create data commons for translational medicine data sets. I'm going to speak a little bit about what we think or how we think a data commons is created and how our Gen3 technology facilitates the creation of those data commons. Then after this brief introduction, I'm going to go in detail to the different steps where our Gen3 technology is using for creating data models and data commons. As some of my colleagues and supervisors here in this paper defined a couple of years ago, a data commons can be defined like a platform where we can collocate data using cloud computing environments and surrounding that data using different software services, tools, and apps in order to manage, visualize, and analyze the data we want to share in order to do an interoperable resource that is useful for the research community. To reach these goals, specifically talking about the Gen3 technology we are presenting here, we define a set of different services that are able to work together to provide that functionality in the data commons. The first of the services we create is FENS that handle the authentication and authorization of the data commons. This service mainly try to identify who is the user that is accessing the data and also provide privacy in a way that we can decide which data sets are available and visible for each user. So we can keep that data set secure. The second of the services is called Sheepdog. It's an API that we use for the user to submit the data, following a very careful design structure in a data dictionary that I'm going to explain a little bit more about the data dictionary in the next slide. The third services we provide in Gen3 technology is Peregrine that also provide a different API that the user can use to extract and retrieve the data they are interested in by using simple GraphQL queries and it determine what is the piece of data in the data commons that they are interested in and create their own virtual cohorts. And the last services we also include in our Gen3 technology is IndexD, which provide a functionality to identify all the piece of data and all the data files we have in the Gen3 technology with a global unique ID in a way that even when the data is moved from one resource to other, the global unique ID it's permanent and unique so we can identify that data. Finally, to facilitate the user the access to these services, we created Windmill, that is an interactive website. It's the front end of our data commons, and user can access through them and have different using interface to easily and in a friendly way access the different services. The Gen3 technology is also important to highlight that is compatible with most of the cloud computing environment like AWS, Google, or Azure, so we can create all data commons in the different cloud environments. As I have said before, one of the key in the creation of the data commons is the design of a data dictionary. We see the data dictionary like a graphical model where we define different categories that we call nodes, and we can also define the relationship between these different categories. For each of these categories, we internally design a list of variables that are the variables that the user can submit to provide metadata to the data commons. This specific, for example, this specific category is biospecimen, and we have a list of variables. And one important thing when we create the data dictionary is that we try to keep these variables mapping to standard terms in known ontologies or known vocabularies like thesaurus or SEDIS. So that's an important thing because even when we create different data commons, if we keep those terms standard across the different commons, we guarantee that we can provide interoperability between the different data commons we are creating. Another important thing in our data dictionaries is that since we have developed several of them, we have collected or we have experience creating the data dictionary in a different data types. Like, for example, we have dictionaries with rich clinical data. We have dictionaries where we include important diagnosis images like MRI. Of course, we have dictionaries creating different sequencing data and other like cell lines data or lab results data. Once we have designed and created that data dictionary, the next step in our Gen3 technology is to submit the data we want to expose in our data commons. This process, we usually define 3 different steps. The first step is identify the data or the data set we want to submit in our data commons and create an ETL process to transform that data in a format that is compatible with the data dictionary we have previously designed. Once we have the data we want to submit converted to the format we expect to have for the data dictionary, we, in the second step, submit the data, usually in TSV or JSON file, using the shipdoc service we have previously described and matching the data dictionary. Once we have submitted all the metadata that we want for our data set, we proceed with the actual data submission, the files, the sequencing file, the MRA files we want to submit, that is also submitted by shipdoc and at the same time is automatically indexed using our indexed service. In the next step, once we have submitted the data, we also provide through our Gen3 technology a personal workspace for users where they can run their own application and their own code to analyze or visualize the data. This is important that it's important to highlight that we index the data in Elasticsearch, so the data exploration and the query of the data is very efficient. It's also important to highlight that this workspace includes Jupyter Hub servers where each user can run their own personal notebook with Python code or R code to do the data analysis and share those notebooks with other users if they want. Finally, our Gen3 technology also support the development of different pipelines, Dockerizing the tool they want to use and also using some typical languages like common workflow language. Just to finish, I would like to invite you to go to this is one of our data commons is open access. It contains data from CCLE, the cancer cell line encyclopedia that includes, for example, copy number variation data, sequencing data, RNA-seq data, array data, together with the different drugs, treatment, and drug response that we can include, we can find in this data set. If you are interested also in creating your own data commons, all our code is open access, including the data dictionary we have been developing for different data commons as all the ones we have here. And you can go through gen3.org where we have documentation, instruction, all the repos where we are collecting the different information from the different, for the different services we have. Also, I want to invite you, if you are interested in discussing about our data commons, the Gen3 technology, to visit our poster this afternoon, A318 at 6, and we can discuss more with our dev team, with all our team about the data dictionary, the data commons and the Gen3 technology. I want to finish and say thank you, a big thank you, and to all my team in the Center for Data Intensive Science that has been working really, really hard to create this Gen3 technology and allowed us to create all the data commons we have been working with. Thank you.
Thank you, Francisco. I'm going to start with a question. It's a very nice framework that you created. I was thinking, at least for cancer data, this can be very useful. And there are also resources like the CBio portal that enable us to explore a lot of cancer data, and they actually make their framework for data visualization available. Is there any plan to connect your framework with CBio portal for cancer data?
We don't have a plan to create, to connect directly with the CBio portal, but it's true that we use the idea that in CBio portal, also in GDC, because it has been developed also in our center, to improve the part of the windmill that is the visualization part. So we have new people in our dev team that are working to create a better visualization so we can provide in all of data commons in a standard way, automated way, similar visualization as in GDC or cBioportal. And we are creating other dictionaries that have partially cancer data, including GDC, but our idea also is that we can interoperate the different. So the part of the data dictionary is very similar and it's compatible with the GDC dictionary. So if we want to interoperate different data commons that we have been building together with the cancer data we have in GDC, it's possible because we have similar data dictionary and they are standardized in a way that we can query in several data commons.
Okay, thank you. Any other questions? If not, thank you, Francisco. And I would like to introduce